Welcome back students to the chapter Haloalkanes and Haloarenes. This is chapter for class 12 and is part 11 of this chapter, and here we are going to discuss questions based on the previous topic, that is free radical halogenation of alkanes. So the first question is, what are the products formed during the free radical chlorination of propane? So we have seen in the last topic about free radical chlorination or halogenation in general, where we can use either chlorine or bromine for this free radical halogenation. So here it is chlorination of propane. So let us see. So we have propane here, and the criteria for free radical chlorination is you need chlorine plus energy. So here it is sunlight that is provided. In the presence of sunlight, H mu means sunlight plus chlorine gives mono substituted chlorination along with a variety of polyhaloalkanes. So what are the mono substituted? Mono substitute means only one chlorine is attached. So here you can see in the first product, in propane, it is the secondary carbon or second carbon that is substituted, whereas another mono substituted is the primary carbon. So we have two products which is mono substituted, and the reaction will not stop there. You will get a variety of polyhaloalkanes. After mono substitution, it will be di substitution, then tri substitution, like that it goes on until every hydrogen is substituted. So whenever you are answering this question, if such a question is coming for your board exam, you should first emphasize on mono substituted products. Then after that you just write a variety of polyhaloalkanes are formed. Clear? So what are the main mono substituted products? There are two. One is the primary carbon substituted, and the other one is secondary carbon substituted product. Clear? Now next question is, among these two products formed here, among which is the major mono substituted product? So among these two products we have primary carbon substitution and secondary carbon substitution. Which is the major product? പ്രൈമറിയിലും സെക്കൻഡറിയിലും വെച്ച് കമ്പയർ ചെയ്യുമ്പോൾ ഏതാണ് കൂടുതൽ അല്ലെങ്കിൽ കൂടുതൽ പ്രയോറിറ്റി കിട്ടുക ആർക്കാണ്? പ്രൈമറിക്കാണോ സെക്കൻഡറിക്കാണോ? ഏത് സബ്സ്റ്റിറ്റ്യൂഷനാണ് കൂടുതൽ പ്രയോറിറ്റി കിട്ടുക? ദാറ്റ്സ് ദ ക്വസ്റ്റ്യൻ ഹിയർ. ക്ലിയർ? സോ ലെറ്റ് us see the answer is secondary. Major product ഏതാണ്? The answer is, so the priority will be for the secondary substitution. Why is it so? It is because among the free radical, so yesterday or in the last class we saw that intermediates are formed here as free radicals. അല്ലേ? Intermediates form ചെയ്യും. ഹൈഡ്രോകാർബണിന്റെ intermediate form ചെയ്യും. One of the intermediate formed during this reaction is hydrocarbon intermediate, and among the hydrocarbon intermediates there are two intermediates formed. ഈ കേസിൽ സെക്കൻഡറിയുടെ കേസിൽ intermediate formed is a secondary carbon free radical. ഇതിനെ വിളിക്കുക carbon free radical എന്നാണ്. Here one hydrogen has gone, and ഇപ്പം ഈ propane look into the secondary carbon atom, its hydrogen is gone as a free radical, and what is remaining is a hydrocarbon free radical with the free radical on the secondary carbon. Whereas other option is the free radical, so which corresponds to this product. ഈ പ്രൊഡക്റ്റിന്റെ ഇന്റർമീഡിയറ്റ് എന്താണ്? is a primary carbon free radical. Clear? So we have secondary carbon free radical, which is the intermediate of this product, and another one is the primary free radical, that is intermediate of this product. ഈ free radical form ചെയ്തതിന്റെ the free radicals formed here, so which one is stable, that product will be preferred. So this intermediate is more stable, so this intermediate will be formed more. അപ്പം ആദ്യം റിയാക്റ്റന്റ് ഉണ്ടാവും, റിയാക്റ്റന്റ് എന്തായി മാറും? ഇന്റർമീഡിയറ്റ് ആയിട്ട് മാറും, അല്ലേ? Then the intermediate will turn into product. like that. So first it will be a reactant. Upon receiving the reagent and the conditions, he will become intermediate. Intermediate ആണ് എന്തായി മാറുക? Product ആയിട്ട് മാറുക. Clear? So first what should be formed is intermediate. Intermediate ഏതാണ് form ചെയ്യുക? The most stable one. And we know now that it is the secondary carbon that is more stable. So it is formed more than the primary. And from here the product is formed. So since it is more stable, it will be formed more. So hence secondary substitution will be more or a major product than the primary substitution. Clear? So in the next slide we will see why is it like that. Why is secondary carbon more stable than the primary carbon? Next question is, if there is a tertiary carbon, which will be more stable? Now here we have only primary and secondary. In case if there is a tertiary carbon, which will be more stable? So this is what we are going to see in the next slide. So for the answer for this question is that it is the secondary monosubstituted compound that is more stable, because the intermediate free radical is more stable here. Why is it like that? Stability of, so whether it is free radical or even if it is a carbocation, we can have the same explanation. We will see that. So in the later parts of this chapter, you will see a species called as carbocation, in which carbon will have a positive sign, in which the entire electrons might have lost. Here only one electron has lost. The resulting species is what we call as free radical. Appo free radical endana? കാർബണിന്റെ ഷെയർ ചെയ്ത ഒരു ഇലക്ട്രോണേ പോകുന്നുള്ളൂ. കാർബോക്കേറ്റയോണിലോ the entire pair is gone. Clear? So let us see stability of carbocation. So if entire sharing electron pair is gone, he will get a plus charge. Clear? So the entire shared pair of electron is gone from here. So he will get a plus charge. It's like this here, plus charge. Now what is the difference between all these plus charge? You can see that carbon is attached to 3 R groups. Clear? 3 R groups, and the fourth bond is belongs to a hydrogen, and that hydrogen is gone. That's why it is getting plus charge. അപ്പോൾ കാർബണിന് അറ്റാച്ച് ചെയ്തിരിക്കുന്നത് 3 R ഗ്രൂപ്പുകളാണ്. What is R group? It can be any alkyl group with a carbon. Clear? Alkyl or any other carbon containing compound. So if any carbon containing compound is attached here and here and here, then that carbon is called tertiary carbon. Whereas here there is only 2 R groups. Rest one is hydrogen. So this is secondary carbon. And here we have only 1 R group, then it is primary carbon. Now if you are comparing the carbon free radical stability. So carbon free radical means it has retained its electron, whereas the hydrogen here has left out with its electron. Hydrogen അതിൻ്റെ ഇലക്ട്രോണുമായിട്ട് പുറത്തുപോയി. കാർബൺ എന്ത് ചെയ്തു? അതിൻ്റെ ഇലക്ട്രോൺ റീറ്റെയിൻ ചെയ്തു. ഇവിടെയോ? ഇവിടെ hydrogen has gone away with the entire shared electrons. That's why it is having plus charge. Here carbon hydrogen പോവാൻ അനുവദിച്ചു with its electron, whereas carbon has retained its electron. Clear? So like here we have tertiary carbocation, carbon free radical. Then here we have secondary, because 2 R group is attached, and here it is primary. So from here it is saying, from the sign itself it is clear, tertiary is more stable in both cases then secondary, and the least stable is primary. എന്തുകൊണ്ടാണ്? What is the reason for this order of stability? Why is tertiary more stable than secondary, which in turn is more stable than primary? Let us see. So R group is an electron releasing group. First of all, the R group is an electron releasing group. So if I have R, this R has a tendency to pull this bond pair of electron towards its neighbor. So R will pull the bond pair. He don't like electrons much, so he will tend to pull the electron. Clear? So R group attached to the electron deficient carbon. So here R is attached to electron deficient carbon. Here also it is like that, because this carbon is short of 1 electron now. Clear? So R group attached to the electron deficient carbon. So it can be carbocation like here, or it can be carbon free radical like here. Both are electron deficient. What happens? This R group will shift their electron cloud towards that electron deficient center. So what he does is he will push that pair of electron, its electron cloud, towards the electron deficient center. So this carbon, what it requires is electron. ഈ കാർബൺ അതിന്റെ സ്റ്റെബിലിറ്റിക്ക് എന്ത് വേണം? ഇലക്ട്രോൺ ആവശ്യമുണ്ട്. ടെർഷ്യറിക്ക് ആവശ്യമുണ്ട്, സെക്കൻഡറിക്ക് ആവശ്യമുണ്ട്, പ്രൈമറിക്ക് ആവശ്യമുണ്ട്. Clear? So these are the intermediates that is formed during a reaction. ഏത് intermediate ആണ് കൂടുതൽ ഫോം ചെയ്യുക? The intermediate which is more stable. Stability കിട്ടണമെങ്കിൽ എന്ത് വേണം? This imbalance due to the shortage of electron must be negated. അല്ലെങ്കിൽ ആ imbalance കുറച്ച് കൊണ്ടുവരണം അല്ലേ? If it has to be balanced well, ബാലൻസ് ചെയ്യണമെങ്കിൽ he should get more electron cloud on it. ഈ കാർബൺ എന്ത് വേണം? കൂടുതൽ ഇലക്ട്രോൺ ക്ലൗഡ് വേണം. എപ്പോഴാണ് കൂടുതൽ ഇലക്ട്രോൺ ക്ലൗഡ് വരിക? when will it get more electron cloud? More R group is attached to it. So here there are 3 R groups. All the R groups will pull electrons or push electron, or push electron towards the carbocation. He will push. So here there are 3 R groups to push because they are electron releasing groups. So by pushing the electron, this carbocation is able to balance that positive charge to a great extent. Whereas here there are only two R groups. R group. So his push will be little lower. And the balancing is not as much as in tertiary. And the least will be for R. And if it is methyl carbocation, it is still less. What is methyl? Instead of R, you will have H here. So more the number of R groups, more will be the stability of this carbocation or carbon free radical. So more the number of R groups, higher will be the stability of electron deficient center. Why? Because there will be more electron density on the unbalanced carbon if there is more R group. So it will be something like this. You can see here 3 R groups is pushing its electron density towards C+. So to some extent this plus charge is compensated. Here also there is push, but only from 2 R groups. So its compensation is little bit less. So it's little bit more unstable. And here you have only 1 R group. So its stability is even lesser. And imagine it is a H group here, which is called methyl carbocation. The stability will be least. So methyl is the least. Then we have monosubstitute, then primary, then secondary and tertiary. So which means that tertiary is more stable and the major product formed will be of that of tertiary. Clear? So more the number of R group, higher will be the stability of electron deficient center. So order of stability of carbocation or carbon free radical is tertiary, which is greater than secondary, and in turn which is greater than primary. Next is, which is the major monosubstituted product formed when ethyl benzene is treated with bromine in the presence of sunlight? So it is ethyl benzene. Let us look into the structure. So this is what is called as ethyl benzene. So on the benzene we have an ethyl group. So ethyl benzene. So it is substituted with bromine in the presence of sunlight. So we have free radical bromination. We have 2 products. One is the substitution taking place on the secondary carbon, and the other one is primary carbon. Generally substitution can also take place on the phenyl ring, but here there is one hydrogen. It requires more energy to remove hydrogen. So mere sunlight is not enough to replace or to substitute hydrogen here by bromine. Whereas in order to substitute hydrogen on this alkyl chain, it requires only very little energy, and sometimes it is even exothermic. Clear? So it is easy to remove hydrogen from this or substitute hydrogen on the alkyl chain, but it is not easy to remove. It is possible, but you need to supply more energy if you need substitution here. Clear? So the initial substitution will take place on the alkyl chain, and the mono substituted products, that the possible two are, one is secondary carbon and the other one is primary carbon, which will be the major mono substituted product. So among these two, which will be the major mono substituted product, of course we have learned it is secondary carbon. So major will be secondary carbon. And what is the reason? Because among the free radical intermediates, in their formation there will be intermediate, free radical intermediates. So what are the two free radical intermediates? One is the intermediate belongs to, the free radical belongs to this carbon, and the other intermediate is the free radical belonging to this carbon. So among, this is primary free radical and this is secondary free radical. So among this primary and secondary, which is more stable, we have learned in the last slide, which is more stable, it is the secondary free radical that is more stable. Clear? So among the free radical intermediates formed, secondary carbon free radical is more stable than primary. Moreover, the free radical is further stabilized by the electron cloud on the benzene ring through resonance. So this benzene ring is very near to this carbon, isn't it? So he is rich in density, rich in electron or negative charge. He will slightly compensate for the deficiency of carbon on this, deficiency of electron on this carbon through resonance, which we will learn in detail later. Okay, so that's the reason.